A ball of mass 0.5 kilograms is thrown vertically downward from the water tower at the University of Kentucky Arboretum. Find the velocity of the ball when it is at the height of 20 meters from the ground if the initial speed with which it is thrown is 10 meters per second. The total height of the water tower is 25 meters. Neglect air resistance. So here we've got uh, from the website Kentucky.com this picture of water tower at the University of Kentucky Arboretum. So what's happening right here is, and this is my rendition of the same, and what's happening here is a ball is thrown downwards from the top of the tower with some velocity, and that velocity is 10 meters per second. The total height of the tower is 25 meters, and we need to figure out what is the velocity of the ball at the distance 20 meters from the tower. So if it is 20 meters from the tower, let's say this is 20 meters, and it's gonna be 5 meters from the top, right? Because 25 meters is the total height, and 20 meters above the ground means 5 meters from the top. So let's look at the equations right here. The equation that we will be using is v equals v naught minus gt, y equals y naught plus v naught t minus half gt square, and v square equals to v naught square minus 2gy minus y naught. And the equations, they take this form because we are using the coordinate system where plus y is above and plus x is to the right. And what I'm going to do now is I'm going to first write down the unknowns and knowns. Well, even before doing that, let's look at this picture and attach our coordinate system on the top of the tower. What that means is we'll have, alright, let's say, let me just rearrange some stuff here. Alright, so what I'm saying is we're going to attach our coordinate system at the top of the tower. Okay, so this is our coordinate system and it is right here, plus y plus x, and this is origin, right? And then let's write down the unknowns and knowns of the equation. What we don't know is the final speed that we call small v, and what we know is that the initial position is 0 because we have attached our coordinate system. Such that origin is right on the top of the water tower, and that is from where the ball is launched in the downward direction, and therefore its position is y naught equals to 0. Alright, we also know that we need to figure out what is the speed or velocity, I should say, of this ball at 5 meters below the top. That means we know that y is going to be minus 5 meters. Alright, we also know the initial velocity with which it was thrown down, and that is minus 10 meters per second. All that remains is to choose the right equation and solve for v. Now I'm going to pick this equation, and this comes with practice, and I'm picking this equation because I know the value of g, y and y naught I know because those quantities are known, and v naught is also known, and I need to figure out what v is, right? So let's solve for it. So let's look at this equation and plug in these numbers. So we've got this equation, and here v square will be equal to v naught square, that is equals to minus 10 minus 2 times 9.81 times the y value is minus 5 and y naught is 0. So if you solve this, minus 10 squared is 100, minus 2 times 9.81 times minus 5, and that gives you 100. Minus times minus is plus. 9.81 times 2 times 5 is 98.1, and this equals 198.1 v squared. This means that v has two possible values, plus minus square root of 198.1. If you solve this, you'll get v equals to plus minus 14.07 meters per second. So if someone asks you what is the speed with which that ball is traveling at 5 meters below the top of the water tower, the answer is just 14.07 meters per second, because again, speed is not a vector quantity, so there's no sign associated with it. It is always a positive number. But if someone asks you what is the velocity, then you will have to also include the direction of the speed. That means in our case it's going to be minus y. So therefore, if the equation is asking us what is the speed, the speed is minus 14.07 meter per second, because in this answer you have encapsulated the magnitude, that is 14.07, and the direction, that is the minus y direction.